geometry students. We're getting ready to do our notes for section 1.3. I'm happy to be working with you again. We're going to do our 1.3 notes in two different sections just because there's so much material in that section. I feel like it's easier to do it as two separate lessons. So right now we're going to do lesson 1.3a. We don't do this that often in terms of breaking it up this way, but I just find it's easier with this section. So at the top of your paper, go ahead and write 1.3a, and then next to that, go ahead and write distance formula. In our last lesson, when we were talking about the distance between 2 points, we introduced that concept, and now I'm going to give you a practical way for actually finding the distance between 2 points, which comes up quite a bit in geometry. So if I were doing this lesson with you in class, I would include a little bit more background information and probably a few more examples, but I'm trying to streamline things for these videos. So I'm going to give you 3 of the most relevant examples I can think of, and then we'll have more time during your Zoom session to go into additional questions or examples that you might like. So what I want to do first is just simply give you the distance formula. This is a formula that we are going to use to calculate the actual number for what is the distance between 2 points. So we're going to write lowercase d, d equals, and then write a really long square root symbol. And then inside that square root, you're going to have 2 sets of parentheses with a plus sign between them. Both of the parentheses are going to have a little squared at the top right corner there, a little number 2 to say that you're squaring the parentheses. So this formula is rather cumbersome to write down, but it's something that you will definitely get used to over the school year. So distance is equal to the square root of, inside the first parentheses, I'm going to write y2 minus y1. Now notice that these numbers here, the 2 and the 1, are down near the bottom of the y, not the top, because I'm not squaring y. It's what's called a subscript. It's a number on the bottom of the letter. And similarly, in the second parentheses, I'm going to write x2 minus x1. Now, please don't freak out about this formula. I wanted to reassure you that this formula is essentially the Pythagorean theorem in disguise. So if you feel at all comfortable with Pythagorean theorem, know that this is Pythag, just in a slightly different looking format. And I will show you how they're similar in just a moment. So what I want to do is just 3 examples with you. For the first example, what I want you to do is write example 1. If you have this on graph paper, it might make it a little bit easier for you to do this one example, but it's really not necessary because we're only going to be actually graphing one of the 3 problems that we work with. So for example 1, what I'd like you to do is to draw your x and y axis. The x-axis is the one that goes from left to right, and the y-axis is the one that goes up and down. And then I would like you to put a point at 1 over and 4 up. And then we can label that 1, 4. You might also want to put an x and a y underneath the 1 and 4. Now remember, you can pause this video if you need to catch up with the graph. The second point I'd like you to plot is the point that is 5 over and 1 up. So 5, 1 is the second point. And what we're going to do with this example is we're going to try to find the distance between those 2 points. For me, the first step is to make sure that both points have been labeled with an x and a y. After I do that, I need to pick 1 point to be my first point and 1 point to be the second point. It doesn't really matter which one is which as long as you pick one and you're consistent and stay with it. So I usually pick the one on the left as being my first point, and I put little 1s on the bottom of the x and y. And then I usually pick the second point on the right to be my second point and put little 2s there. Now, if I want to plug all this information into the distance formula, I'd like you to see if you can figure out what the first number I'm looking for is using this formula. So look at the formula that you have here, look at the information you have here, and see if you can tell me what the first number would be. The first number I'm looking for in the distance formula is y2. for this problem, y2 is the number 1. So I'm going to write 1 minus. Now the next number I'm looking for is y1. And in the context of this problem, that number is 4. So I'm going to write 1 minus 4. That's my first parentheses. Now for the second parentheses, I'm looking for x's. x2 is going to be the number 5. So I'm going to write a 5 here. And then x1 is the number 1. So now I have all of my numbers put into my formula. Now we're going to talk about positives and negatives for a minute. If I want to take 1 minus 4, there's a couple ways I can think of that. One is to look at 1 on my number line, and then from 1, go 4 to the left. Notice that I end up at -3. If you're not as much a visual thinker, but maybe auditory, you can think of it as the difference between 1 and 4 is 3. And since the bigger number is negative, my answer is negative. So the answer to the calculation inside the first parentheses is -3. Then, for the next parentheses, I need to take 5 minus 1, which is, of course, 4. Now, -3 squared means -3 times -3, which is 9. And 4 squared is 16. Don't forget to keep the radical sign flowing throughout the whole problem here. I end up with the square root of 25, which is 5. Now, I'm wondering, if you remember a minute ago I said that the distance formula is basically the Pythagorean theorem in disguise. Can anybody look at their notes and see how I could have gotten that 5 using Pythag instead of this big, long, complicated formula? Look at your notes for a minute and see if you can figure that out. What is it that you could have done to solve this using Pythag? If you want to draw a triangle here, it might help you visualize it. I'm going to draw 2 legs of a triangle with a box here showing that that's a right angle. Notice that the length of this leg is 1, 2, 3 units long, so I'm going to put a 3 here. The length of this leg is 1, 2, 3, 4 units long, so I'm going to put a 4 here. Can you see how this is a 3, 4, 5 right triangle, just like the one we talked about in our lesson on Pythag? So you could have gotten the 5 by drawing this triangle and then doing Pythag. 3 squared plus 4 squared equals d squared. Notice that's very similar to what we were doing here. This was -3 squared, but negative times negative is positive. We end up with the actual same work in the end. 25 equals d squared, and then take the square root to get d is 5. So most students do appreciate having the distance formula because it means you don't have to draw a graph every time you want to find the distance between 2 points and draw in the triangle and all that. But I did have one student a few years ago who chose to use Pythagorean theorem the whole year. He didn't use the distance formula once, but he, as far as I remember, got his distance problems correct because he knew how to draw the triangle and do Pythag, and he did just fine. So it's kind of a personal preference thing, but it can be somewhat time consuming to draw all this. So let's do another example where we don't draw the picture but just use the formula. Let's use the points -1, 2, and I'm purposely including some negatives here, by the way, to show you a little bit of a different aspect of this formula. And then also the point 11, -3. So remember, the first thing we want to do is label the points with an X and Y. And then pick a first point and a second point. And again, I usually go from left to right. It's your preference. Whatever you like, you'll get the same answer either way. I'm going to write the distance formula here just because when we're first, beginning to use the distance formula, it can be kind of helpful to have it written down on every problem. You don't have to do that, but it can be a visual tool for you. Now what I'd like you to do is see if you can figure out what numbers you would put in for the formula. So I'm going to give you about half a minute, and I'd like you to see if you can fill in the numbers for the distance formula. All right. What you're going to want to do is find y2 first. y2 is -3. So I'm going to do -3. I'm going to bring down the minus sign, and my y1 is 2. So my first parentheses is -3 minus 2 quantity squared. Now let's look at the second parentheses. For the second parentheses, I need x2, which is 11. I'm going to bring down the minus sign, and then x1 is -1. Now here's something really important to notice. Notice that I have 2 minus signs in a row here. Can you remember what happens when you have 2 minus signs in a row? What happens is it turns into a plus. So as I do this work now, I need to keep that in mind. Let's talk about this problem with the negatives here. -3 minus 2. That would be what I would get if I started at -3 and I went 2 more in the negative direction. I would end up at -5. So my first parentheses is -5 squared. My second parentheses, 11 plus 1, is 12 squared. Now remember, negative times negative is positive. So -5 times -5 is 25. And then 12 times 12 is 144. When we add these together, we get 169. And the square root of 169 is 13. So the distance between those 2 points is 13. Now, for those of you that are kind of like really into math, I purposely picked this example because this was essentially a 5, 12, 13 triangle, which is another very common right triangle. And I'm trying to give you lots of examples of those throughout the school year so you'll be familiar with identifying them. The main thing I want you to take away from this, though, is how to use the distance formula in that context. Now, what I also want to do is give you one more example. We did examples 1 and 2. I'd like to do one last example, example number 3, because this is a problem that comes up on your homework. And sometimes students can be a little bit more intimidated by the word problems. And so when I can, I like to include an example similar to the homework in my notes. So we're going to make this one be example number 3. And I will read this to you. Please don't feel like you need to write it down again. We're kind of streamlining things now. But I'll write the picture on the board for you. So the problem says a square has a side length of 6 centimeters. What is the length of the diagonal of the square? What is the length from the corner to the center of the square? Explain. So a good tip when you're doing a word problem like this is to draw a picture of the problem. Since they're asking us about a square, I'm going to draw a picture of a square. They also told me that the side lengths were 6. So I'm going to put 6s on all sides. Now, the first question it's asking me is what is the length of the diagonal? If you draw a diagonal through a square, you can see that you make a right triangle. So we can do Pythag here, if we would like, to solve this problem. So if I'm trying to find the length, I can put an x here perhaps, and I will say 6 squared plus 6 squared equals x squared, or 36 plus 36 equals x squared, or 72 equals x squared. Now, I kind of like this part of the problem because not only are we referring back to our first lesson, the lesson on Pythag, but we're also going to refer back now to our second lesson, the one on radicals. Because when I take a square root here, square root of 72, I want to simplify that. It is true that x is the square root of 72, but I'm technically not done. The reason is because there's some pairs there. If we do a factor tree for 72, I can see that 72 is 2 times 36. And to keep this kind of simple, I'm just going to write 36 as 6 times 6. Now this is a fairly detailed long example, but like I said, we're going to be done with this video when this problem is done. All right, so we're going to write x is the square root of 72, or x is the square root of 2 times 6 times 6. Can anybody remember what I do next? Some of you may have said, oh, I see a pair there. You are right. You take out that pair and you leave the 2 in. So the answer to the first question, what's the length of the diagonal, is it is 6 radical 2, and we should probably write down centimeters. Now, they did ask another question. It was, what is the length from the corner to the center of the square? What they're really saying is, what is half of the diagonal? So if I was going to go to this point right here, what would half of that diagonal be? Well, half of x would be 1/2 times 6 times radical 2, or 3 radical 2. So the answer to the second part of the question is 3 radical 2. All right, so we finished our notes on 1.3a. This will help you to do all the distance problems on your worksheets. You are going to be completing all of 1.3 worksheets, the practice A, practice B, and puzzle time. But not all of them are distance problems. Some of them are midpoint problems. So in order to do all of the worksheets, you are going to need to listen to the second 1.3 lesson. Thanks so much, guys.